So far, what we have learned on the normal probability distribution has to do with some of its basic characteristics and how the empirical rule can be used to approximate probabilities for areas under the curve. So, at this point, we're ready to put a formal cap and describe the general properties of the normal distribution curve. First, the normal distribution curve is always symmetrical about its mean. So the mean value, the most typical value usually observed in the population, is usually the point at which you have an almost even divide, approximately speaking. Then, second condition is that the mean, the mode, and the median are usually equal. And so the normal curve has a single peak or the highest point where x, the random variable of interest, is equal to its mean. Then one standard deviation above, which takes you to the mean plus the standard deviation, and one standard deviation below, which takes you to mean minus one step below. These two are called the points of inflection. Then again, the next property is that the whole area under the curve represents probabilities. And since probabilities usually sum up to 1, the area has a size of 1. So the area under the curve is always totally equal to 1. Then, and so that means that the area to the left and to the right of the mean, the center value, will be equals to 1/2. Then finally, note that when you draw the normal distribution curve, the curve comes very close, asymptotically speaking, to the x-axis, but never really touches the horizontal axis. So whenever we find that a random variable has a normal distribution, that is, its relative frequency distribution can be drawn in this form, you have two descriptors or two parameters, the mean, the center value, and the standard deviation, the measure of how spread away all other values are away from the typical value. With that said, we now go on into using technology rather than the empirical rule to find probabilities which are not for regions which are not 1, 2, or 3 standard deviations from the mean. So to illustrate that, we are going to take an example. Using technology, calculate the required probabilities for the normal distributions with the parameters specified in parts A through E. We have the mean, 5, and the standard deviation is 5, and would like to compute this probability. When I am given a question like this, what I like to do is immediately I first sketch the normal distribution and I locate the mean first of all and pay attention to the standard deviation on the side. And then once you write the mean, it is easy to answer this question because you're looking at the number 0, which should be to the right of 5, and the number 6, 0 should be to the left of 5, and 6, which is to the right of 5. So the region I want to find the probability is this region. And to find the size of that region, I can use technology, namely StatCrunch in this case. So here I am in StatCrunch. I will go to Statistics, go to Calculators, this time to the normal distribution. Click on that. And then I will need to set the mean and the standard deviation. Going back to my notes, my mean is 5. My standard deviation is also 5. Okay, so I want 5 and 5. And this time I want area between. So I'm going to click on between, and between 0 and 6 and hit compute. So between 0 and 6, which matches exactly the question, and I have my answer, which is 0.4206. So 0.4206. For question B, the mean is still 5 However, the standard deviation has changed, but I'm still finding the same region. So 0 from 0 to 6. And I will locate this region. And once I locate that region, I want to find the probability in that region. From this question to this question, the only thing that has changed is the standard deviation. So I'm going to alter that, set it to 4 and hit enter. So I have 0.4931. And I'll take that back here, 0.4931. Then for the next question, my mean is 7. So I'll locate 7 and I want the probability less than 6. 6 should be to the left of 7 and I want the region to the left of 6. So I'm going that way. I'm going this way. This probability, let's go. So back here, I need to set my mean to 7 and my standard deviation is 5. Remember, mean is 7, standard deviation is 5, and I want an area below 6. So I am going to adjust this to standard, and I have below 6, and compute. I can see that it is 0.4207. So I have 0.4207. Then for the next question, question D, the mean is 6 and I want to find probability connected with 4 and I want the area above 4. So above 4 would be this region. Or for the sake of illustration here, I can do this again. So I'm going to set up the parameters. So I have the mean is 6 and standard deviation is 3. So the mean is 6 and standard deviation is 3. And I want the area above, so greater than or equal to what value? Greater than 4. So I'm going to set that up 4 and hit the enter button. So I have 0.7475. So we have 0.7475. Done. We now proceed to the next example. In this example, we are told that suppose the monthly charges for cell phones are normally distributed. So that means the random variable of interest, x, here, is normally distributed with a mean of this value and a standard with a mean of $57 and a standard deviation of $19. I will write x having the normal distribution. The mean is 57. Standard deviation is 19. Question A. Draw a normal curve with the parameters labeled. I'll draw my normal curve and I'll locate the mean of 57 and the standard deviation is 19. Then question B. Shade the region that represents the proportion of plants that charge less than $38. Proportion is synonymous to probability. Number of charges, x, that charge less than 38. So I'll replicate this same graph. So I have 57. I'm going to locate 38 and I'm interested in the region below 38 in this case. So let's see what that is. We have already shaded that region, which is what the question requires us to do. Then in question C, we have to find the size of this area we shaded in part B above. In other words, what that means is we should compute the probability that a randomly selected cell phone plan has a monthly charge lesser than $38. We're also required to provide an interpretation of this result. So let's do that. So first of all, I want to find this region, the size of this region, the probability of x less than 38, and I will head over into StatCrunch. I need my parameters, 57 and 19. So let's go there. Mean is 57 and 19. And I want the region where it is less than 38. So I'm going to change less than or equal to 38 and hit the compute button, which gives me 0.1587 approximately 0.1587. And then it is time to provide an interpretation of this result. The interpretation will be the proportion of cell phone plans that charge lesser than $38 monthly is 0.1587. With that question completed, we are now ready to move on to another example. In this example, we are told that suppose the lengths of human pregnancies are normally distributed with 266 days and standard deviation of 16 days. Complete parts A and B below. So, I have already condensed them into just this piece. This figure right here represents the normal curve with a mean, the center value of 266, and a standard deviation of 16 days. So the area to the left of x equals what? X equals 250 is 0.1587. We're to provide two interpretations of this area. Here we go. 1. The proportion of human pregnancies that last less than 250 days in this region is 0.1587. That is one possible interpretation. And the second interpretation is that, secondly, the probability that a randomly selected human pregnancy lasts less than 250 days is 0.1587. These are two possible interpretations of this region. We now proceed to the next example. Assume that the random variable x is normally distributed with a mean of 50 and a standard deviation of 7. We are to compute the probability that x is greater than 41. Be sure to draw a normal curve with the area corresponding to the probability shaded. So in this case, we're dealing with a normal distribution. So we'll draw the normal curve and we'll locate first the mean. The mean is 50. And we'd like to compute the probability that x is greater than 41. I will locate 41 and I want the region to the right of 41, which represents the region for values of x greater than 41. So probability that x is greater than 41 is equal to, let's go to start crunch, key in these parameter values, 50 and 7. So I'm going to do that here, 50 and 7. And I want the probability of x greater than or equal to 41. Now compute that, that's 0.9007. So taking that back, 0.9007. Just to be sure, let's check again. 0.9007. Yes. All right, that question is completed. With that question completed, I would like to talk about a special normal random variable called the standard normal distribution. Now, usually if you start out with x having the normal distribution with a mean and a standard deviation, this is just the regular standard normal random variable. We can convert it to the standard normal random variable, which is usually represented by the capital letter Z. And in this case, we're going towards a normal random variable whose mean is always 0 and the standard deviation is standardized at 1. So how do we convert from x to z? Usually, if you start out with your x, if you subtract the mean of the values of x and divide by the standard deviation, the corresponding values will all be z values. Let's see an example of this conversion. So we have a random variable from a normally distributed population x that has this mean and the standard deviation. So this is mean of 200 and a standard deviation of 20. We have to get the standardized z value. So when x is 225, the standardized z value that will correspond to this value of x is 225, the raw value of x, which is what we are saying here, x value, minus the mean, which is 200, divided by the standard deviation, which is 20, and that will give you 25 divided by 20, which is 1.25. Then we have x equals 190. The z value corresponding to this will be 190 minus the same mean that we're given in this question. Let's erase this a little bit so it looks neater. Divided by 20. This will be negative 10 over 20 or negative 0.5. And you have 240. That will be z equals 240 minus 200 divided by 20. And that will be 40 rather, divided by 20, which is 2.0. Each of these values are all z values that would constitute the z distribution corresponding to this x distribution. Remember that we did this earlier in chapter 3, and we learned that since this is positive and this is positive, this indicates that each of these x values are above the mean value of x, whereas since this is negative, it indicates that 190 is below the mean of 200. With the definition of the standard normal random variable out of the way, we now want to compute, in the next example, probabilities connected with the z random variable. Immediately this question said this is a standardized normal distribution. I know immediately that the mean is always going to be 0 and the standard deviation is always going to be 1 because it has been standardized to these set values, fixed and sure. All right, with that said, I'd like to find this probability. So I am interested in the number 1.7, positive number, and I would like to compute the probability less than. So I'm looking at this region, and I'll go to Start Crunch. In Start Crunch, I'll set my mean to 0, my standard deviation to 1, and I'm interested in less than or equal to what value? Less than or equal to 1.7. So I will key that in here, 1.7, and I have 0.9554. So I can do that. This is equal to 0.9554. Then for question B, well, observe again, just to remind us, this is without less than, this is without equal to, rather, but this is with equal to. These are exactly, as far as continuous random variables are concerned, these are exactly the same region, so I have the same answer. This is just to remind us of that. Then, the probability that z is greater than or equal to 1.7, I have my standard normal curve, the standard, the mean, which is 0, the standard deviation is 1, 1.7 is a positive number, and I want the region above. So right here. So that will be 1 minus this probability, or going back to Start Crunch, I only need to change this to greater than or equal to, and it gives me 0.04457. So take that back here to my working board. So I have equal to 0.04457. Then for this probability on question D, probability that z is greater than negative 2.05, I will locate 0, I'll locate my negative number, and I'll locate the region, which is to the right. So, to the right. So I have equals, let's see, going back, I do not need to change the mean and standard deviation since I'm still dealing with a standardized normal random variable. I only need to change, I still have greater than or equal to, since it's an area to the right. I change this to negative 2.05. So here I go, negative 2.05, and compute. So you have 0.9798 taken to 4 decimal places. So here we go, 0.9798. Then for the next question, this is between. So I have my mean, 0. I have my negative value. And I have my positive value. And so in this case, I need to indicate that I'm looking at a region between two values, between negative 1.19 and 1.15, I believe, just to be sure. Yep, negative 1.19 and positive 1.15. So I'm going to compute that. That is 0.7579. So we take that back here. This region, the size is equal to 0.7579. And in a similar fashion, we can do question F and G. So I have the mean is 0. You have negative 0.19 and 1.04. You can go ahead, pause the video, and try to do this ahead. Then unpause and check if your answer matches the one I have done. So we're looking at this region, and that will be equal to 0.4262 from StatCrunch. And then for the last one, we're going to have 0, negative 1.19, and this is 1.19, and this is this region. And if you go into StatCrunch and you key in these values, I'm going to do that again. So I'm just going to need to change this to 19 and hit enter. I'll have 0.7660 because taken to 4 decimal places, this for 59 becomes 60. So 0.7660. And we are done with that question. So this gives a quick exercise or set of problems relating to the standardized normal random variable, which we're going to be using a lot later in the inferential part of this course.